So the ideology behind these corner devices is to just to uh, compare the actual value with that of the ideal one. Okay, so this we have discussed in the last class. So now in today's lecture, what we are going to see is an important problem. Okay, wherein we are going to combine two devices, and we will be analyzing how efficiencies or COPs are being find out when it is being coupled. Okay, when it is being combined. So problem based on heat engine and refrigerator plant. So heat engine is a separate device and refrigerator is a separate device. So we are going to combine heat engine and refrigerator, and we are going to solve a problem on this setup. Then we are going to discuss something called randomness, which is the next topic of this, and the entropy concept. A new fellow is entering our topic, which is called as entropy, and the second law of thermodynamics based on entropy. Remember, we are discussing the topic of second law of thermodynamics. Okay, so in the first module it is first law of thermodynamics, in the second module it is second law of thermodynamics. And what we are discussing this in this heat engine, refrigerator or heat pump is nothing but second law of thermodynamics only, based on Kelvin statement and Clausius statement. Okay, and we shall end up this session by discussing the example for entropies. So now we shall take this problem, look at this problem very carefully. We are going to spend much time in understanding the question as usual. Okay, shall we proceed? Shall we proceed?
Sir.
Yes, sir.
Audio is clear?
Clear, sir.
Okay,
Yes.
so the first sentence is a reversible heat engine. So the first sentence of this problem is a reversible heat engine. So you have to note down each and every word, because in each and every keywords we have some data. Now here a reversible heat engine means it is an ideal heat engine. Okay, so all the data related to this reversible heat engine, we are going to find out something called Carnot values. Okay, so if this reversible was not given, simply a heat engine operates means it is an actual engine. Here it is mentioned a reversible heat engine, ideal heat engine, Carnot heat engine. Everything or everything is having same meaning. So here a reversible heat engine means it is an ideal which will not exist in reality, but we are discussing just for the problems. Okay, a reversible heat engine operates between reservoirs at temperature of 600 degrees centigrade and 40 degrees centigrade. So we all know that heat engine operates between higher temperature and lower temperature. Higher temperature, from the higher temperature it receives the heat, it converts that heat into work by rejecting some amount of heat at the lower temperature. Okay, so let us quickly draw the heat engine, something like this. Let us say that heat engine is the layout of heat engine is like this. Okay, and it is a reversible heat engine. It is operating between two reservoirs. One is at 600 degrees centigrade and another one is at 40 degrees centigrade. Let us have a device, a setup like this. Okay, so this is the setup for the first sentence, in which reversible heat engine is operating between two temperatures. We have already discussed that higher temperature will be named as T1, lower temperature will always be named as T2. Now it is receiving heat from the higher temperature. Okay, heat engine is receiving the heat from the higher temperature. Now it will do some work here, and it rejects some heat to the sink or lower temperature. Sink is nothing but lower temperature. Now read the second sentence. The engine drives a reversible refrigerator. Okay, heat engine is also reversible. Now it is driving a refrigerator. What does it mean? We will be getting some work output from the heat engine. Okay, so it is doing some work here now, which will be connected to a refrigerator. Heat engine produces work, refrigerator consumes work. So the output of this heat engine is taken and given to the refrigerator. That is what it means. And that refrigerator operates between reservoirs of 40 degrees centigrade and minus 20 degrees centigrade. Okay. So the heat transfer to the heat engine. So I'll draw the refrigerator quickly now. The heat transfer to the heat engine is 2000 kilojoule. So the heat transfer from the hot source to the heat engine is 2000 kilojoule. So since this is T1, I name this as Q1. Okay. And the net work output from the combined engine refrigerator plant is 360 kilojoule. I'll come to this point later. So now quickly let us draw uh, the refrigerator plant. Okay, so now let us take these two devices separately. First, as heat engine, it receives heat from higher temperature T1, and with the heat receiving as Q1, and it rejects heat Q2 to the temperature T2. Now what it happens? It produces some work. Okay, this heat engine is producing some work, and this work is being given to the refrigerator. So where is the refrigerator? This refrigerator is here. Heat engine is producing work. That work is given to refrigerator. Okay, now you can understand easily, right? So the engine drives a reversible refrigerator which operates between reservoirs at temperature of 40 degrees centigrade and minus 20 degrees centigrade. So it is having a higher temperature of 40 and lower temperature of minus 20 degrees centigrade. So it will be something looking like this. Okay. So since we are having already T1 and T2 here for heat engine, so what we will do is we will take T3 as higher temperature and T4 as lower temperature for refrigerator. So T1 and T2 is connected or related to heat engine. T3 and T4 is connected to refrigerator. Or T3 and T4 are the reservoir temperatures of the refrigerator. Okay. Now, is there any clarification here? Any clarification you want to make?
Yes, sir.
Yes, please. That's புரியலையாப்பா?
Puri, sir.
Okay, okay. So heat engine is giving work output and refrigerator is taking work input from the work which is being produced by the heat engine. Okay. Now let us say this T3, okay, with heat which is given to atmosphere as Q3 and the heat which is taken from the cold space as Q4. So T1 Q1, T2 Q2, T3 Q3, and T4 Q4. This you can name it as you wish. 1 2 3 4 should not be in the same, it need not be in same order. You can give Q1 here, Q2 here, Q3 here, Q4 here as you wish. Okay. It is just for better understanding that we are giving higher temperature as T1 and lower temperature for T2 for the heat engine. Now we are having another device. So we are going for T3 for higher temperature and T4 for lower temperature. Okay. So four temperatures, four heats. This heat is work is produced by the engine. Refrigerator is receiving the work. Now coming to the question. So the heat transfer to the heat engine is 2000 kilojoule, and the net work output from the combined engine refrigerator plant is 360 kilojoule. So what does it mean? It is producing some work. Let us say for example 100 kilojoule. Heat engine is producing 100 kilojoule of work. Okay. So all the 100 kilojoule is not given to refrigerator. Some part of the 100 kilojoule is given to the refrigerator. Let us say that out of 100, 40 kilojoule is given to refrigerator. So 100 is being produced here. The blue line is 100. Say just for example, if the blue line in the blue line 100 kilojoule of work is being produced, but to the refrigerator only 40 kilojoule is supplied. So what is the remaining? The 60 kilojoule is the net work output which is coming out of these two plant. Okay, after being produced, after is being expensed, as if you are earning 100 rupees and you are expensing 40 rupees. So now what is the balance? The net balance is 60 rupees, like that. So now it says that the net work output from the combined engine refrigerator plant is 360 kilojoule. So how it can be? Let us say that W1 is the total work which is being produced by the heat engine. Let us say W1. This W1, let us say for example 100. This W1 is, let us say for example 100, and this W2 is, say for example 40. So this 100 is totally produced. This 40 is given to the refrigerator plant. So what will be here? What will be here? What will be here at the down area of green
60,
color?
60, sir.
So 100 is here, 40 is here, means remaining 60 will be here. So that is the W net. So it is given as W net equal to W1 minus W2. Now we have taken example of 60. Now in the question it is given that it is 360, meaning suppose 100 kilo, sorry, 1000 kilojoule of work is being produced by the engine. Okay, then W2 how much? 640. Okay, 640, yes, it is 640. Okay, 640 or 540? Yes, it is 640. So W2 is 640. Just for I'm telling an example. If W1 is 1000, if W1 is 1000, then W2 is 640. So that then the net is 360. We do not know what is W1, what is W2. We do not know what is W1 and what is W2 after being expense. Okay, so we are getting the balance as 360, as if we do not know how much we earn and we do not know how much we have expense, but the net balance in our pocket is 360 rupees, like that. Okay, we do not know how much we have earned. How much we have earned is W1, how much we have expense is W2. So earn minus expense is the net balance. So the net balance is 360 kilojoule, which is coming out of these two plant as 360 kilojoule. Have you understood the question? Any clarification in the question? तुम्ही question ला doubt irukappa?
Clear, sir. Clear, sir.
Clear, right? Okay. Now we shall proceed with the question part of it. So what is that we need to find? It has two parts. One, the first part is the evaluate the heat transfer to the refrigerant. Evaluate the heat transfer to the refrigerant. So what is that? Anybody? So we are having four heats here: Q1, Q2, Q3, Q4. Q1 is the heat supplied to the heat engine. Q2 is the heat rejected from the heat engine. Q3 is the heat rejected from the refrigerator. And Q4 is the heat supplied to the refrigerator. Now evaluate the heat transfer to the refrigerant. Means what? Q1, Q2, Q3, Q4. Which is the correct answer? இது கரெக்ட் ஆன்சர். இந்த நாலுல நம்ம எது ஃபைண்ட் பண்ணணும்? Evaluate the heat transfer to the refrigerant means what? It is something related to refrigerator. அது மட்டும் புரியுது இல்லையா? Evaluate the heat transfer to the refrigerant means it is something related to refrigerator, not heat engine. So it is definitely not Q1, Q2. In the evaluate the heat transfer to the refrigerant வந்து இது Q1 Q2 கிடையாது. Because that is related to heat engine. Now the heat transfer to the refrigerant means it is something related to refrigerator. We do not know whether it is Q4 or Q3. So refrigerant means what? Refrigerant is a liquid or two-phase fluid which is flowing inside the refrigerator. Okay, so that is circulated for producing the cooling effect. So now what we are doing in the cooling cold space is we are removing the heat from the cold space and it is being supplied to the atmosphere. So what will happen when when you have the cold space? Suppose that you are keeping apple, uh, meat, and milk, etc., in the cold space. Okay, and it will be at, say for example, at a temperature of 20. When you keep it inside the refrigerator, before keeping it, it will be an ambient temperature of 25 degrees centigrade. So now once you keep it inside the refrigerator box, the temperature reduces. So now once temperature reduces, the cooling effect is being produced by the two-phase fluid, which is called as refrigerant. And the gas சொல்லுவாங்கல்ல, refrigerator குள்ள இருக்கிற gas சொல்லுவாங்க. We in the local term we used to call that as gas. Okay, all the mechanics of refrigerator, they will be calling it as gas. Okay, so that gas will become hot by cooling this cold space. That gas will become hot. Okay, or in other words, we could say that all the heat from the cold space is being taken by the refrigerant which is flowing inside the refrigerator. Okay, so now what is q4? Q4 is the heat taken from the cold space and given to the refrigerant, or in other words, we could say that Q4 is the heat supplied from the cold space to the refrigerator or to the refrigerant. And what is this Q3? This Q3 is the heat which is rejected to the atmosphere. Okay, now tell me, he evaluate the heat transfer to the refrigerant, means Q4 or Q3? சொல்லுங்க சார், it is Q3 or Q4? சொல்லுங்க, ஆன் பண்ணிட்டு ஆஃப் பண்ணிட்டாரு.
Q4, sir.
It is Q4 only. Exactly, it is Q4. Okay, so that is the heat which is being supplied from the cold space to the refrigerant. So the first question is we need to find this Q4. Okay, and what is the second part of the second session of the first part? Evaluate the heat transfer to the refrigerant and the net heat transfer to the reservoir at 40 degrees centigrade. So the net means we are having more than one. Okay, so net heat transfer to the reservoir at 40 degrees centigrade. So these four red color boxes, T1 is one reservoir, T2 is one reservoir, T3 is one other reservoir, and T4 is another reservoir. Okay, so heat engine is working between two reservoirs and refrigerator is working between two reservoirs. So they are asking the question, the net heat transfer to the reservoir at 40 degrees centigrade. So which is 40 degrees centigrade? 140 degrees centigrade here. So they are asking Q2. What is this Q2 which is being transferred to 40 degrees centigrade? We are having one more 40 degrees centigrade here, which is Q3. So we need to add Q2 and Q3. Okay, so the net heat transfer to the reservoir at 40 degrees centigrade. So what are all the heat which is being transferred to the reservoir at 40 degrees centigrade? 40 degrees centigrade இருக்கிற ரிசர்வாயருக்கு எந்த ஹீட் எல்லாம் ட்ரான்ஸ்ஃபர் ஆகுதோ அந்த ஹீட் ட்ரான்ஸ்ஃபர் நம்ம கண்டுபிடிக்கணும். Okay, so this 600 is not 40, minus 20 is not 40. So we are having two 40 degrees centigrade here, which is T2 and T3, or the heat is Q2 and Q3. So that is the first part of the question. You keep this part B as it is. Once we solve the problem, then we will come to the part B later. So as of now, we need to find what is Q4 and what is Q2 plus Q3. Have you understood the question? The question புரிஞ்சுச்சுனா almost we are done. Okay, so we shall proceed to the solution part. So what we'll do is, so it will be very confusing if you take these two devices together. Okay, if you take these two devices together, it will be very much confusing. So what we'll do is we will split the problem into two parts. One is the problem with respect to heat engine, the another one is problem with respect to refrigerator. Then we will combine, then it will be an easy way to solve the problem. Otherwise, if you have this combined diagram, it will be looking like very, it is very complex. So what we'll do is we'll split it into two half. Okay, as if you have two reservoir and heat engine and W1. The second part, we're having two reservoir, refrigerator, and W2. Okay, so first we shall take the part of heat engine. as if you are having a heat engine, you are having a reservoir at 600 degrees centigrade and a sink at 40 degrees centigrade, and it is producing W1 work, as simple as that. Okay. Now what is that we need to find? The first question, as we have discussed, we need to find Q4. If you see this diagram, this first question is, okay, this evaluate the heat transfer to the refrigerant is, first question is Q4. The second part of the question is Q2 plus Q3. Okay, so the second question is Q2 plus Q3. If you could find these two parameters, our problem is over. So what is that? If you see the problem, only Q1 is given, right? In this problem, Q1 is given. We need to find Q2, Q3, Q4, as simple as that. எல்லா ஹீட் ட்ரான்ஸ்ஃபர் கண்டுபிடிக்கணும். ஓகே, Q1 மட்டும் தான் கொடுத்துருக்காங்க. Q2, Q3, Q4 மூணுமே கண்டுபிடிக்கணும். So once Q4 is a separate answer, once we find Q2 and Q3, we can add it. That is the second part of the question. Okay. ஏதாச்சும் நடுவில் புரியலன்னா ப்ளீஸ் ஸ்டாப் மீ, ஐ வில் கிளாரிஃபை யுவர் டவுட்ஸ். ஓகே, இட் இஸ் வெரி இம்பார்ட்டன்ட் ப்ராப்ளம். Okay, so once I give this material to you, it may look like very simple. Okay, but once you practice it, uh, many of you used to do the mistake which is very trivial. Okay, which is very simple mistake you should not do. So please listen it very carefully. Okay, so going to the solution part. So T1 is given as 600 degrees centigrade. Quickly convert that into Kelvin. And similarly, T2 is given as 40 degrees centigrade. Quickly convert that into Kelvin. So now we are going for, and Q1 is given as 2000 kilojoule. Okay, put it as it is. So these are the given datas. Now we need to find Q4. First, we cannot find Q4 here because Q4 is related to refrigerator, which is a second part of this problem. So first we will go for Q2. இது புரியுதா? இந்த Q3யும் Q4ம் வந்து ரெஃப்ரிஜரேட்டருக்கு சம்பந்தப்பட்டது. ஸோ இந்த பார்ட்ல, ஹீட் இன்ஜினோட பார்ட்ல, we can only find Q2 only. Okay, so with this heat engine, the only unknown that we can find is Q2 only. Okay, so this Q3 and Q4 we need to find while considering the refrigerator. Okay, so first we shall find what is this Q2. So the aim of this heat engine slide is just to find what is this Q2, nothing else. Okay, and this Q3, Q4 will be found out in the using the refrigerator diagram. Okay, so these are the given data. Now it is given that it is reversible heat engine. In the question itself, just that's what I told. It is given that a reversible heat engine. Reversible means ideal, theoretical, Carnot, whatever it is. Okay, so therefore what we can write, the efficiency of this heat engine can be written as the output by input. Output is W1 for this, and Q1 is the input for this. So which can again be written as Q1 minus Q2 divided by Q1. So now since it is reversible or Carnot, this Q can be written in terms of temperatures. Any clarification in this? We have solved this, we have solved problem using this equation. That is why I have solved problem separately for heat engine, separately for refrigerator, separately for heat pump, so that if it is combined, then you can easily understand. Okay, so W1 is the output, Q1 is the input. Actually it is Q1 here. Okay, I'm sorry for the mistake, it is Q1 here. So I'll make a change for now, otherwise it will go disturb. This is Q1. Okay, I'm sorry for that. So Q1 minus Q2 divided by Q1, that can be written as T1 minus T2 divided by T1. Now can we find efficiency? If you use this equation, Q1 minus Q2 by Q1, we cannot find the efficiency. Okay, but if you use this temperature equation, we can easily find what is the efficiency. So quickly substitute the temperature. Efficiency of heat engine is equal to T1 minus T2 divided by T1. So that is equal to 0.642 or 64.2%. Okay, so you should not get confused when to use W1 by Q1, when to use this Q1 minus Q2 by Q1, and when to use this T1 minus T2 by T1. Okay, this blue color equation T1 minus T2 by T1 can be used only if the engine is reversible, or if the engine is Carnot, or if the engine is ideal, theoretical. These keywords should be there. Then only we can use this T1 minus T2 by T1 equations. Otherwise, we cannot use. Then this W1 by Q1, this equation can be used at any point of time for any problem. Okay, we are using just this because of the keyword of reversible heat engines. Now what we can find from this? So efficiency of heat engine equal to 0.642. So what we can find from this? So this efficiency is 0.642. So 0.642 equal to W1 by Q1. Q1 is given. Can we find W1 from this? Quickly find out. கண்டுபிடிக்கலாமா? 0.642 is the efficiency of heat engine, that is equal to W1 by Q1. W1 is unknown, Q1 is given in the problem as 2000. So W1 equal to efficiency of heat engine into Q1. Muhammad Arshad, சொல்லுப்பா பார்க்கலாம். எவ்வளவு வருதுன்னு சொல்லுங்க பார்க்கலாம். What is the value of Q1 you are getting? Just multiply.
கால்குலேட்டர் இல்லை சார்.
தெரியும். நோட் இருக்கா? ஃபோன் இருக்கு, ஹெட்ஃபோன் இருக்கு, அவ்வளவுதான். கார்த்திக்.
Sir, yes, sir. 1 second, sir.
ஓகே, இது கேட்குறப்போ ரொம்ப ஈஸியாக தான் இருக்கும். While you solve the problem, that's it.
Sir, 1284, sir.
1284, excellent, thank you.
Thank you,
So
sir.
also efficiency of heat engine is equal to W1 by Q1. Okay, so which implies W1 equal to, sorry, 0.642 equal to W1 by 2000. Therefore W1 equal to 1284 kilojoule. So this is not the answer. This is not the answer for this part. What is that we are trying to find out? இது சொல்லுப்பா பார்க்கலாம். முகமது அர்ஷத், இந்த ஸ்லைட்ல வந்து நம்ம என்ன, what is that we are trying to find out with this heat engine? You tell me at least this. முகமது அர்ஷத், கேள்வி கேட்கறப்போ நிறைய பேர் வெளியே போறாங்க. Zahan, you tell me. Zahan. AM Zahan. Okay, Hanan. Okay, what
Yes,
is
sir.
that we are trying to find out with this slide? In the slide
Q4.
Q4 வந்து இதுல வராது. Q4 இந்த ஸ்லைட்ல எங்குமே இல்ல.
In this side, we are trying to W1, sir.
No, W1 we have found out. Okay, that is not the
Okay.
answer. Okay, with this heat engine, what is that we are trying to find out? Yes, somebody said it is Q2. Okay, it is
Q2. Okay, sir.
Q2 மட்டும் தான் நம்ம எய்மே வந்து Q1, Q2, Q3, Q4 4 Q கண்டுபிடிக்கணும். அதுல Q1
Okay.
கொடுத்துட்டாங்க. Q2, Q3, Q4 is unknown. Okay, so with this heat engine we can only find Q2. Q3 and Q4 is related to refrigerator. Okay, thank you.
Okay, sir. Thank you, sir.
So please listen it carefully. That is why I'm asking the question, not to make you disturb. Okay, so just to make it clear that to make it very simple. Okay, otherwise the problem is very easy. Okay, now W1 we have found out. So what we have to do, we have to find out Q2. Now from this diagram, Q1 is entering and W1 and Q2 is going out. So I can write this Q1 is equal to W1 plus Q2. Okay, from the diagram, Q1 is equal to W1 plus Q2. So this one entry, it like if you take this as A, this as B, this as C. So A equal to B plus C. So A is entering, B plus C is going out. So I write B1 W1 plus Q2. So Q1 is given in the problem. W1 just now we have found out, and Q2 can be easily found out. Okay. So Q2 is coming as 716 kilojoule. What the answer is 716? So please try to
Yes, sir.
calculate it. 716 kilojoule is the answer for Q2. So Q2 is the heat rejected to the sink at 40 degrees centigrade. If we can find out Q3, then we can add Q2 and Q3. We will get one part of our problem. Okay, but it is half of the second part. Only Q2 we have found out. So now for finding Q3 and Q4, we shall go to the refrigerator plant. Okay. Any clarification in this slide? Any doubt?
No, sir.
Okay, we shall proceed then. Now we are going to draw the refrigerator plant. Okay, so this is the half diagram of our problem. Okay, so we have the refrigerator. From the cold space, it is transferring the heat to the higher temperature, for which it need W2. So W1 is the work produced by the heat engine. W2 is the work consumed by the refrigerator. Okay, so it is as if 1000 rupees I have earned. So W1 is 1000. So I am expensing W2 here. Let us say 560 kilojoule means, so the W2 is the work which is being consumed from the refrigerator, consumed by the refrigerator. Okay. So now here we have Q3 and Q4, which we can easily find out. In the problem, we have already we know that the net work output. Okay, the net work output. So if you go back to the this slide, okay, here W net equal to W1 minus W2. W1 is the total work, W2 is the expense, selevu senjadu. See, this W net is the balance, okay, remaining. So we know that W net is equal to W1 minus W2 equal to 360. So just now we have found out W1. Okay, so I can easily calculate 360 is equal to 1284 minus W2. So what will be W2 then? W2 is equal to 924 kilojoule. Okay, so this is the work which is being consumed by the refrigerator to transfer the heat from minus 20 degrees centigrade to 40 degrees centigrade. ஓகே, ஸோ இவ்வளோ தான் வந்து ரெஃப்ரிஜரேட்டர் கன்சியூம் பண்ணியிருக்கு. டோட்டலாக வந்து 1284ல் 924 வந்து கன்சியூம் பண்ணியிருக்கு. மிச்சம் வந்து 360 கிலோஜூல். ஓகே, ஸோ தி ரிமைனிங் ஹீட் ஒர்க் இஸ் 360 கிலோஜூல். ஓகே, now we have got W2. In the problem itself, it is given that T3 is equal to 40 or 313 Kelvin, T4 equal to minus 20 or 253 Kelvin. Okay, and it is also given that the refrigerator is reversible. Similar to heat engine, the refrigerator is also reversible. So reversible means what? We can use Carnot formula. Okay, and for heat engine it is efficiency. For refrigerator it is going to be something called COP. Okay, we have already discussed in the last class itself. For heat engine it is going to be efficiency. For heat pump and refrigerator it is going to be COP. Okay, so I can write COP of the refrigerator is equal to the desired effect is Q4 divided by the work input is W2, that is equal to Q4 divided by Q3 minus Q4. So this is the formula for COP, but since it is reversible, I can write Q4 as T4 divided by T3 minus T4. Clear? So similar to what we have wrote for efficiency, we can write the same similar equation for COP of refrigerator. So Q4 can be written as T4, Q3 minus Q4 can be written as T3 minus T4. Now COP quickly we have to substitute 253 divided by 313 minus 253 is equal to 4.22. So what is this 4.22? Efficiency na purida. 100 out of 100 it is 64%. Out of 100 it is 70%. So what is this 4.22 means? So this 4.22 is the ideal value of this refrigerator. Okay. So what does it mean ideal value? An actual refrigerator, okay, in reality, an actual refrigerator working between these two temperatures cannot have COP beyond 4.22. Okay, 4.22 may be the maximum value of COP that this refrigerator can achieve, meaning any refrigerator working between these two temperatures cannot have COP above 4.22, 4.5, 4.6 அப்படின்னு சொல்லி ஒரு சிஓபி இந்த மாதிரி ரெஃப்ரிஜரேட்டருக்கு இருக்காது. ஓகே, ஒர்க்கிங் பிட்வீன் தீஸ் டூ டெம்பரேச்சர்ஸ் இட் கேன் ஹாவ் தி மேக்ஸிமம் ஆஃப் 4.22 ஒன்லி. ஓகே, தட் இஸ் த மீனிங் ஆஃப் சிஓபி maximum or COP Carnot. Okay, we are using the Carnot because of the reversible. Now, so also COP of refrigerator is equal to Q4 divided by W2. Okay, so COP just now we have found out. So 4.22 is equal to Q4 divided by W2. This W2 we have already found out here above. Okay, so this W2 is equal to 924 kilojoule. So we are substituting that. So we will be getting Q4 as 3899. Okay, so we have got Q4. Okay, and we need to calculate Q3. Okay, so for finding Q3, what we are doing is W2 is equal to Q3 minus Q4, or I could say W2 plus Q4 is equal to Q3. If this is A, if this is B, if this is C, so A plus B equal to C. Okay, or A equal to C minus B, like this. Okay, so this equation we know W2 equal to Q3 minus Q4 from this diagram itself. Any clarification? நிಮಗೆ ஏதாச்சும் டவுட் இருக்குன்னா ப்ளீஸ் stop me, I'll explain. Okay, so W2 equal to Q3 minus Q4. So W2 already we have found out, Q3 is unknown, Q4 just now we have found out. So Q3 is equal to 4823 kilojoule. Okay, so we have got Q3 and Q4. Q3 and Q4 we have got from this refrigerator plant. Okay, so what we can do, so Q3 plus Q2, which is the total net heat transferred to 40 degrees centigrade. Okay, just add Q3 from here and Q2 from the previous slide. Okay, 716 kilojoule from previous slide, you will get 5539 as the total heat transferred to the reservoir at 40 degrees centigrade. Okay, so now, and this is separate answer. Okay, Q4 is a separate answer. The heat supplied to the refrigerator at, or the heat supplied to the refrigerant. Any clarification?
No, sir.
Your problem is over. Okay, we have found out what is the heat supplied to the refrigerant and the total heat supplied to 40 degrees centigrade. So Q4 we have found out, Q3 plus Q2 also we have found out. Okay, if you go back to the previous slides. Okay, so this Q4 is what was required, and the total heat to 40 degrees centigrade is this Q2 plus this Q3. Okay, we have found out. Now, what is the second part of the problem? Second part of the problem is, if actual COP of the refrigerator is 40% of the ideal and efficiency is 40% of the ideal. Suppose, say for example, we have found out COP and efficiency, right? In this second slide, we have found out efficiency is 64.2. Okay, So this is the maximum efficiency this engine can produce. This is the maximum possible efficiency this engine can produce. What is the second question? So what we have found out here, 0.642 or 64.2 is the ideal efficiency or theoretical efficiency, because we have used the reversible engine concept, or we have used the Carnot formula to find out the efficiency of the heat engine. Okay, now in the second part, if you have any actual heat engine, say for example I'll say for example your efficiency of the actual is only 40% of efficiency of the ideal. What does it mean? The efficiency of actual equal to 40 by 100 into efficiency of ideal means 0.642. 0.642. So you'll be getting actual efficiency. Okay, like this, by finding this way you can find the actual efficiency. And similarly the COP, similarly if you take this COP is 4.22 is the ideal one. So what is COP actual? For this problem they have given, if actual COP is 40% of the COP ideal and efficiency actual is 40% of the ideal, then find Q2, Q3, Q4 again after finding the new efficiency. Okay, so how to do that? So I leave it to you. Okay, just a minute. So this the problem is over. The second part of the problem I leave it to you. Okay, second, solve the second part of the problem by yourself. So I'll give some hint. Okay, so how to do that? So new efficiency for the same problem, let us say that new efficiency is efficiency star. Efficiency star equal to 0.4 of efficiency of heating. So what is this? This we have already found out. This black color is what we have found out. Okay, so this is 0.642. Okay, so this fellow this fellow we have already found out as 0.642 in the first slide. Okay, and this we have found out as 4.22. So we have to find new efficiency by multiplying 0.4. What is the 0.4? 40%. 0.4 into 0.642, you'll be getting one more efficiency. With that we have to find W1. You'll be getting a new Q2, then we'll be getting new W2 here, then COP will be new, then we'll be getting new Q4, new Q3. So Q2, Q3, Q4, again we have to calculate using the same method as we have found out for the ideal case. Okay, so this is the hint number one, to find out the efficiency first. Then what is the second hint? Second hint is the recalculate the new value for Q2, W1 and W2 from efficiency star. Okay, what is this efficiency star? It is zero point 0.4 into efficiency of the heat engine. So this efficiency of the heat engine is 0.642. We have already found out. Then determine the corresponding Q3 and Q4 from new COP. So new COP is zero point 0.4 into COP. This COP is nothing but 4.22. Okay, so I'll share this image, the image of this slide. Okay, if you want to take the screenshot, you can take it. Otherwise I'll share this image of this slide, okay, to your group. You have to solve it. Okay, so I have told you many problems in between to solve by yourself. Okay, so you have to keep those problems ready. If I ask for assignments, you have to upload those problems. Okay, it is not just to show that solve by yourself slide without any meaning. Okay, So you have to make a note that it is given as tutorial problems so that you practice well. Okay. So till here the problem is over. Any clarification in this problem? ஏதாச்சும் புரியலையாப்பா? So Rohit,
Yes, sir. Clear, sir.
clear, right?
Yes, sir.
So if you understand it very clearly, I make sure that you need not prepare again this topic. It is very simple and it is very logical also. Okay, you can remember it easily. Otherwise, you have to it will appear as more complex problems. Okay, so I leave it to you for further references. Okay, so till here we have completed the second law of thermodynamics for heat engine and heat pump and refrigerator. Okay, that is Clausius statement and Kelvin statement. So we have started, if you remember, we have started the unit by discussing the second law of thermodynamics, and we have said that it can be discussed in three ways. The first one is heat engine Kelvin Planck statement. Okay, we have seen a number of problems, more problems on this, and heat pump and refrigerator Clausius statement. Okay, so option A, heat engine is efficiency. Option B, heat pump and refrigerator is COP. And we have one more way of defining the second law of thermodynamics, which is nothing but it is based on something called entropy. Have you heard this word entropy anywhere? யாராச்சும் கேள்விப்பட்டிருக்கீங்களாப்பா? முகமது இப்ராஹிம். Ibrahim is here.
Yes, sir.
Entropy, have you heard it?
Yes, sir. I have heard it, but I don't know, sir. Now I don't remember it.
Just now you have heard, huh?
No, sir.
Hmm.
12th standard.
12th standard you have heard it.
Yes,
Okay,
sir.
Surya, have you heard this word entropy?
Yes, sir.
Do you remember something related to entropy? I don't
Uh,
expect the exact definition. If you tell, it is
it is
excellent.
a thermodynamics, sir.
Sorry, sorry.
It is a heat thermodynamics, sir.
Uh,
Heat thermodynamic.
அவ்வளவுதான். That's what you remember, huh? Okay, no issues. Okay, now we shall discuss this topic entropy. Okay, with which you shall remember this word entropy forever. Okay, it is the better way of understanding any concept is to have the discussion with the example. Okay, so we shall take a classic example to understand what is this entropy called. Okay, so second law of thermodynamics based on entropy. Okay, before we go for second law of thermodynamics, we shall have a discussion on something called randomness. Okay, so what is mean by random? Random you have heard, and random you will better understand, right? What is random? No fall irkara? No fall Akram? No, he is not here. Imad, can you say what is random? On பண்ணிட்டாரு. What is random?
Hello?
Random
Sir,
ஏதாச்சும் சொல்லுங்க.
random means uh,
புரியுது சார்,
uh,
சொல்ல தெரியல சார்.
as
உங்களுக்கு புரியுதுன்னு சொல்லி எனக்கு புரியுது.
sir,
Okay.
in a flow or
Random is something which is not in order.
as
As simple as that. ரொம்ப வந்து ஸ்பெசிஃபிக்கா சயின்டிஃபிக் டெஃபினிஷன்ல வேணாம். ரைட்? Thank you. So random is something, which is not proper, which is not in order, okay, which is not scheduled in every aspects we can discuss. Okay. So in concept of thermodynamics, we could say that the movement of molecules is known as randomness. It is moving not in a perfect manner. It move as it wishes. Okay, it move randomly somewhere here or the other. Okay, so we will come to this line later. So first we shall have uh, a look on this image. So what is this image tells you? There are some students which are sitting with proper arrangement. Okay, supposed to be a very strict teacher. Okay, and it is he or she is handling a mathematics topic called algebra. Okay, so everyone is quiet, and they are not talking, and they are not disturbed, and they are sitting, properly arranged structure. Okay, and what is this image tells? Okay, they are telling, okay, this image is telling that okay, no one is there, so we shall play, we shall roam as we wishes. Okay, no proper lines, no proper arrangement, so everyone is having their own wish. Okay, whatever he or she wishes, he or she does. Okay, so what is the difference between these two? The first one is, properly arranged. The second one is properly not arranged, or it is randomness. So the first image tells that randomness is very, very, very low. Okay, or order is very, very high, properly arranged, highly ordered. Okay, in the second image, randomness is very high, or orderness is very low. Okay, so let us take one word itself. We shall take randomness. So we have first image on the left hand side, second image on the right hand side. For the first image, that is on the left hand side, randomness is very low. For the second image, randomness is very, very high. Now it will be very clear, right, what is randomness. Now once it is coming to the molecule, the same concept is being applied. Okay, we have solid, we have liquid, and we have gases. Now can anybody tell me which matter of which state of matter is having high randomness?
Gas.
Gases. And solid is having very least grade of randomness, and liquid is in between solid and gases. Okay, so this is what we call it as the randomness. Okay, now if we have understood what is randomness, then we can easily understand what entropy is. Okay, so entropy is the movement of randomness of the system is called as entropy. Okay, if the randomness is very high, entropy is very high. If randomness is very low, entropy is very low. Okay, in other words, it is the measurement of disorder of the system. Okay, now tell me, out of these three state, which is having more entropy, which is having least entropy? இந்த மூணுல எதுல வந்து ரொம்ப அதிகமா entropy இருக்கு? இதுல
Gas also.
gas is having high entropy.
Yes, sir.
Yes, so more randomness means more entropy, less randomness means less entropy, as simple as that. Okay, so it is defined, it is a measurement of disorderness. Okay, or it is a measurement of the randomness. Okay, that is what we call it as entropy. So as we discussed, solid is having very least entropy, gas are having very high entropy, and liquid is having entropy between solid and gases. Okay, so it is given by some formula. Okay, the entropy change is equal to change in heat with respect to temperature. Okay, so we shall discuss this. Okay, with respect to an example. So S is the symbol defined for entropy, like H is the symbol defined for enthalpy. Can you remember once we were discussing the topic of entropy, sorry, enthalpy, we have used this word, right? So dH is equal to uh, just a minute. Okay, okay, pointer. So dH or del H is equal to dq at constant pressure. Okay, so this is what we have discussed. Now if you see, del S is del Q at constant temperature. Okay, so entropy and enthalpy are related like this. Okay, so del S is equal to del Q divided by T. Del S is here the entropy change. Okay, so what is the entropy before process and what is the entropy after the process? Suppose that we are heating the gas. Okay, so S1 will be the entropy before heating, S2 will be the entropy after heating. So the change in entropy will be equal to heat supplied at constant temperature. Okay, that is the equation for entropy change. Now now we have defined what is entropy. As simple as that, entropy is the degree of disorderness or measurement of randomness. Now we are going to define the second law of thermodynamics. Okay, in all the spontaneous process, spontaneous means automatic process, it occurs without any force. Okay, spontaneously it occurs in all the spontaneous process. Can you tell me any spontaneous process in thermodynamics? தெர்மோடைனமிக்ஸ்ல ஏதாச்சும் ஒரு ஸ்பான்டேனியஸ் ப்ராசஸ் சொல்லுங்க பார்க்கலாம். மிஸ்டர் யார் கேட்கலாம்? மிஸ்டர் பிரின்ஸ், you tell me any one spontaneous process. Spontaneous process means which occurs automatically. Prince Melvis, okay, he is not responding. Rohit,
Sir,
ஏதாச்சும் ஒரு spontaneous process சொல்லுங்க பார்க்கலாம். We
the
have
heat
already
transfer,
the heat transfer from
sir, atmosphere to in
atmosphere to
refrigerator like this, sir.
இப்படி சொல்லலாம். நீங்க வந்து ஒரு காஃபி வந்து டேபிள் வச்சிட்டீங்க. Okay, you have kept a coffee or you have kept a hot body in the atmosphere in the ambient room. So the heat is going to transfer from the hot body to the cold body spontaneously without any force,
Yes, sir.
right?
Yes,
That is
sir.
called spontaneous process, which can occur on its own. Thank you.
Yes, sir.
So in all the spontaneous process, the entropy of the universe increases. So what does it mean? So this is the equation. The entropy change of the universe is always greater than zero. So what we have in the universe? We have system and we have surrounding. We have discussed in the first class. So what is system, what is surrounding? Suppose that I take a beaker of water. I take a beaker of water and I want to do some analysis on the beaker of water. Okay, so beaker of water is my system. So what is surrounding? Apart from system, everything is surrounding. So what is there in universe? I have system and surrounding. If you add system and surrounding, that is my universe. Okay, so entropy change of the universe is always going to be greater than zero. Or in the universe, I have system and surrounding, nothing else. Wherever I go, I have only system and surrounding. Okay, so if you add these two entropy changes, it is going to be always greater than zero. So it is going to be a little bit confusing. While we discuss with an example, then it is going to be very clear. Okay, so by knowing, okay, the entropy change, we could say that, okay, whether the process is possible or not. Okay, or whether the process occurs on its own or it is non-spontaneous. Okay, so if it is still confusing, so now we shall go directly to an example. Okay, so now we can understand easily what entropy is. Let us say a cup of coffee. Okay, and the coffee is at 50 degrees centigrade and the ambient temperature is, surrounding temperature is 20 degrees centigrade. Okay, so now heat transfer will takes place. Now there are two possibilities or there are two cases. The first case is the heat will transfer from the coffee to the environment. The second case is the heat may transfer from the environment to the coffee. So there are two possible cases, or there are two cases. I should not say two possible cases. There are two cases. One is from the coffee to the surrounding, or from the surrounding to the coffee. So we shall discuss two cases. So let us take case one, in which coffee absorbs heat from the surrounding. So what does it mean? The heat is supplied from the surrounding to the coffee. Okay, So the heat is getting transferred from 20 degrees centigrade to 50 degrees centigrade. Let us say, without any common sense, let us say that, let us have a discussion on case 1, wherein hot coffee is absorbing heat from the cold environment. Okay, and let us say that it is receiving 10 joule. Okay, let us say that it is receiving 10 joule of heat from the surrounding. So what is the case 1? From the surrounding to the coffee. Okay, let us say that Q system. Now what is system? System is coffee. System is receiving plus 10 joule. Since it is receiving, it is plus 10 joule, and surrounding is losing heat of 10 joule. So if this 10 joule is entering the system, the surrounding is losing. இவர் 10 ரூபாய் சிஸ்டம் கொடுக்குறாருன்னு சொன்னா இவருக்கு வந்து சரௌண்டிங் வந்து 10 ரூபாய் வந்து it is losing. Okay, so whatever heat is entering the system, that is being lost by the surrounding. So heat is rejected from the surrounding to the system, so I put minus sign here. Okay, so from where it is coming, from the surrounding to where it is going, to the system. Okay, so heat is supplied means plus, heat is rejected means minus. So system is rejecting the heat now to the system. So let us apply the entropy formula. Delta S of universe equal to delta S of system plus surrounding. Universe equal to system plus surrounding, and we know that delta S equal to del Q by T. So del Q by T for system, del Q by T for surrounding. Okay, system, surrounding. I am just applying the formula of let a minute. So del S equal to del Q by T. I am applying this formula here. Okay, for each system and surrounding. So del Q system is 10. Okay, by T system. System is 50 degree centigrade or 323 Kelvin, plus minus 10 divided by 293 Kelvin, which is of the surrounding. So what is the answer? The answer is coming as, okay, delta S is equal to minus 0.00316 joule per Kelvin. Just let us say, for example. So what is happening? This is negative value. So what does it mean? But delta S of universe is always greater than 0. It violates second law of thermodynamics. So what is the conclusion? We could now say that the process is non-spontaneous. இந்த மாதிரி ஒரு ஹீட் சரௌண்டிங்ல இருந்து சிஸ்டமுக்கு போகணும்னு சொன்னா தானா நடக்கவே நடக்காது. If the heat has to enter from the surrounding to the system, provided the surrounding is very cold and the system is very hot. Okay, to transfer the heat from the cold environment to the hot system, it is not possible spontaneously. So this process will not occur. Okay, now let us take the case 2. Okay, same coffee 50 and 20. Now coffee is releasing the heat to the surrounding. Okay, so the heat is going from the system to the surrounding, so it is minus sign here. Okay, so it is minus sign here because system is rejecting the heat. So Q system equal to minus 10, Q surrounding equal to plus 10, delta S equal to system plus surrounding, universe equal to system plus surrounding. So applying the formula, so what I get, delta S of the universe equal to plus 0.00316. So this is positive value, but delta S universe is greater than 0. It obeys the second law of thermodynamics. We could now say that it is spontaneous process. Okay, so it is looking like very trivial, right? சார் என்ன சார் ஹாட் காஃபி வச்சுட்டு வந்து காஃபிலேருந்து ஹீட் வெளியே போகுமா, இல்லை வெளிலேருந்து காஃபிக்கு ஹீட் உள்ளே வருமான்றது வந்து இட் இஸ் வெரி சிம்பிள், வெரி ட்ரிவியல். ஸோ அவர் காமன் சென்ஸ் சேஸ் தட் it is always the heat will transfer from the hot coffee to the cold environment. Okay, so yes, your guess is correct. Okay, we already know that coffee is going to lose heat to the surrounding, but in some chemical process this prediction is very very difficult. Okay, whether that process will occur or not, there is a spontaneous or not, it is very difficult. So what we have to do, we have to go for entropy change. If the entropy change is positive, then that process will occur. If the entropy change is negative, that process will not occur. Okay, so for to check the feasibility of the process, whether that process is spontaneous or it will not occur, we are going to find out the entropy change. Okay, like what we have done in this case. Okay, so that is why this second law of thermodynamics is used. Okay, so if the entropy change is positive, we could say that okay, that process is possible. So if you could remember, we have discussed in the limitations of first law of thermodynamics, in which we have discussed that first law of thermodynamics fails to say the direction of the heat transfer. Okay, and it fails to check whether the process is possible or not. Okay, second law of thermodynamics based on entropy says that okay, so it is possible or not possible, we can easily find out from the second law of thermodynamics. How we can find out? If delta S of the universe, okay, if it is greater than 0, then it is spontaneous. If it is less than or equal to 0, then it is non-spontaneous, or that process will not occur. Okay, so that is the second law of thermodynamics. Now you might have understand the importance of the second law of thermodynamics, right? So that is the topic of discussion today. Any clarification till now? So what we have discussed, to summarize, so we have taken the problem on the combined heat engine and refrigerator plant, and we have defined what is randomness, we have defined what is entropy, and we have discussed what is the entropy with an example. Okay, and we have discussed the second law of thermodynamics based on entropy. Okay, so any clarification?
No, sir.
ஏன் தம்பி நிறைய பேர் வெளியே போயிட்டு போயிட்டு வரீங்க, என்னன்னு ப்ராப்ளம் தெரியல. Everything is being recorded. Okay, how many times you have went out, how many times you have came in, everything is recorded. Okay, no issues. So if there are no issues, I shall end this session. Okay, I'll take the attendance. Zahan was present. Vinoj, Ibrahim, Naufal is absent. Jabid is absent. Imad is present. Prince. நான் பதில் சொல்லவே இல்லையா அவங்களாம். Prince, he did not switch on his mic. mic problem வரும் இப்போ. Vinudayam, Sharan was present. Khalis is absent. Okay, present பண்ணல. Yes, 80% is absent. Absent.
Sir, present, sir. Vinoj.
Vinoj present. இது absent ஆகட்டும்னா. first is present.
Sir, Prince present, sir.
Presentக்கு மட்டும் தான் மைக் ஆன் பண்றீங்க. கேள்வி கேட்டா ஆன் பண்ண மாட்டீங்க. Falakram is absent. Jabir is absent. Okay, Vinudayam, Sharan, Khalis is absent. Arvind Raj, Karthik, Arshad, Hanan, Rohit. Okay. So if there are no questions, we shall end up this session. Okay. Have a nice day. Thank you.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you,
Thank you,
sir.
sir.